Hi guys, in this video exercise we're going to be sketching a complex curve. What's the curve? Let me read it to you. It's y equals x plus 1 on x. We're going to take it in 3 stages. Stage number 1, we're going to find the first derivative, and that's going to yield where the stationary points are. So we're going to get some x values there. Once we get them, we're going to take those values and substitute them back into the original equation to find the corresponding y values. Then we're going to mark it out over here on the number plane so we can kind of get a visual on it. And then after that, we'll get the second derivative so we can find the nature of those points. Are they concave up, concave down? Is there any inflection points, etc.? We're going to look for those. And then finally, something interesting, because this is a complex curve, we're going to look and search for some possibilities that there may be an asymptote or two. So you may want to think about why we might have asymptotes on this particular function. Some of you can see it already, but in a moment, most of you will discover it. So what I'm going to do is I'm going to start at part 1, and I'm just going to find the first derivative. But before we do that, we need to do something. We need to put this in a format that makes it differentiation friendly. In other words, we're going to put it in a format that we can easily derive. So to find the derivative. So this is what we do. We're going to put it into y equals x plus x to the power of minus 1. Now they're exactly the same. They're identical, but it's a lot easier to use this to find the derivative, to differentiate. So now it's differentiation friendly. So now let's begin for this part 1 and find the derivative. So let me call it f prime x, which is the same as dy dx, equals find the derivative of x, that's 1. And then we have this negative 1 goes to the front, changes the sign, so it's negative x. We drop the power by 1, and that becomes negative 2. So there's our first derivative. Now, what do we do with the first derivative? To find stationary points, make it equal 0, that's right. So let's make that equal 0. Actually, let's write it out like this, 1 minus 1 over x squared, because that's essentially what it is. Make that equal 0. Let's multiply both sides by x squared. So that means if we multiply that by x squared, that by x squared, and that by x squared, we're left with a value of x squared minus 1 equals 0. Now that's a difference of 2 squares. You can do it a multitude of ways. I like to throw this over that side and make it x squared equals 1. Square root both sides, therefore what we have is x equals plus or minus 1. So there are x values where there's stationary points. We're going to take these guys and slide and substitute them back here into the original equation and find those corresponding y values. So let's do that now. So when x equals 1 and I substitute 1 into the original function up here, that will be 1 plus 1 on 1. Let me just do that over here. Function 1 equals 1 plus 1 over 1. Well, what's that going to equal? That's 1 plus 1, which equals 2. So when x equals 1, the coordinates are 1, 2. So we have a stationary point there. Let's find the next point, which is at negative 1. Function negative 1, make that clearer, equals negative 1. And then we have a negative 1 there. It's plus minus, we'll make it into a minus, so it's minus 1 on 1. So it's negative 1 minus another 1, which makes it negative 2. So the next stationary point is at the point negative 1, negative 2. So we have 2 stationary points, but we don't know their nature. Are they maximums or minimums? So we're about to discover by finding the second derivative. So we're going to find the second derivative to this right over here. So let's do that now. Let's find the second derivative. So let's find that second derivative. Here's our first derivative. So f double prime, f double dash, second derivative equals differentiate 1, just that's a constant, so that's going to be 0. And we have a negative 2 comes to the front, becomes positive, so that's plus x to the power of, drop it by 1, plus 2 to the negative 3. So that's plus 2 x to the negative 3. We could also write that down as this format. We could have a 2 here over x cubed. That's our second derivative. Okay, now to find the nature, let's find out when we substitute the x values that we found the 2 stationary points of 1 here and negative 1. So I'm going to substitute the point of 1 first of all. So f of 1 equals 2 over 1 and that simply equals 2. And that's greater than 0, isn't it? Which means it's going to be a what point? It's going to be a minimum, isn't it? So that's a minimum. Minimum point. Let's put in the second point for -1, f double prime -1 equals, so that's going to be 2 all over -1 to the power of 3. Now that's still going to stay negative because when you have a negative power with a negative number, with a odd power or exponent up there, it's going to stay negative, isn't it? So 2 over a negative number is going to be negative, which means it's less than 0. So this part here clearly is going to be a maximum. So we've got a minimum and a maximum. So let me just write them up here. So the 1, 2, the power 1 here, that's going to be a min. And this part here is a maximum. So why don't I just go ahead and mark them out up here on the number plane. So our first point here is at 1, 2. Looks like that's going to be a minimum. And the next point at -1 and -2, that looks like it's going to be a maximum. That's a maximum, that's a minimum. Okay. All right, so we've got them there. Now there's one other element I mentioned at the beginning, and that is to consider the possibility that we may have some asymptotes. Well, how do we know there are asymptotes? Well, let's try when we have two things happening, when x approaches 0 and x approaches infinity. What do you think is going to happen? Well, if x approaches 0, let's try that. Let's say x approaches 0. Now what's going to happen as x approaches 0? Well, if that's 0 here, that means this area here will be undefined. So clearly that's not going to happen. So at x equals 0, which is code for the y-axis, we're going to have an asymptote. So let me just put that up here. Now oftentimes many teachers don't require you to do this, but I'm putting it in so we can see it. So there's our asymptote right over there. I'll just put it next to the y-axis. So that curve, that maximum minimum that we have, is not actually going to touch this part, the y-axis. So there's our first asymptote. Now let's try when x approaches infinity. So what do you think is going to happen there? So let me just write up here. When x approaches infinity. Well, if it approaches infinity and we substitute it here on the right-hand side, on the denominator where the x is, well, that's going to be 1 over infinity. That's going to approach 0. So if that approaches 0, we're left with the x. That means y is approaching x. So therefore, we have an asymptote at y equals x. So let me write that down. At y equals x, we have an asymptote, y, I'll repeat that again. That's because 1 over infinity, like that, approaches 0, doesn't it? When the denominator gets bigger and bigger, the whole number becomes smaller and approaches 0. So y equals x, our next asymptote. So let me mark that out. Y equals x. That's going to look something approximately like, goes through 0, 0. Something like that, approximately. There we have, that's our maximum point there. So there's our asymptote, the first one and the second one. So our curves are going to fit really snugly inside these 2 points right over there. So why don't I go ahead and put them in. So the first one is going to be a minimum at 1, 2. So 1, 2 is going to be a minimum. 1, 2, there's a minimum, so it's going to go around like that. So let me just draw that in right now. There we go, like that. There we have it. All right, there's our minimum right there. And the second point right there, that's a maximum. As it says, a maximum, -1 and -2. Let's mark that out over here. So that's going to be about something like that, approximately. All right, there we have it. Let me just mark up the actual coordinates again. We have the minimum of 1, 2. There's 1, 2. And then we have the maximum here of -1, -2. That's our maximum there.